Good morning, students. Today we'll learn about two group CX disconnection in that 1,2 difunctional compounds. So in that, let us take alcohols. In the two group CX disconnection, which is 1,2 disconnection, the numbering starts from the carbon atom bearing the functional group. By 1,2 disconnection approach, we mean that the two functional groups being disconnected are at relative 1 and 2 positions. The short form of two group 1,2 disconnection approach is 1,2 DIX. Some examples are hydroxy ethers and amino alcohol. So let us study their examples. So the first one is hydroxy ether. So now you can see that the carbon which is attached to the hydroxyl group is be numbered 1 and the adjacent carbon to the left is numbered 2. So since here we are disconnecting the carbon 2 and the oxygen, you can see the disconnection mark. So that's the reason why this kind of disconnection is called 1,2 disconnection. So after writing the retrosynthetic arrow, we are on the top, we're going to write down as 1,2 disconnection. Now the synthetic equivalence is going to be 2 alcohols. So this way you can disconnect 1,2 disconnections. Now another example is amino alcohol. See, in amino alcohol also, since these are all examples for alcohols, we are going to always we're going to focus on the examples for alcohols. So here you can see that the carbon which is attached to the hydroxyl group is being numbered 1 and the adjacent carbon is numbered as 2. And then we are going to disconnect the second carbon and the amine, that is the C and N bond is being disconnected, and hence this is also example for 1,2 disconnection. I hope this part is clear. So after disconnecting, we are going to get a primary amine and a synthon, that is an alcoholic cationic synthon we are going to get. So now the equivalent for this alcoholic cation is going to be an epoxide. So here we have the lone pair on oxygen which will be given to the positive charge of carbon atom, and hence we are going to get a three-membered chain, that three-membered ring, which is the epoxide with oxygen in it. So that is the epoxide. So next we'll learn some more examples. So example 2 is the disconnection of phenylramidol gave two molecules, that is 2-aminopyridine and the synthon. The synthon is obtained from the reagent styrene oxide. The synthesis has been achieved by the reaction of 2-aminopyridine and styrene oxide in the presence of strong base like sodamide in liquid ammonia. So here we have the target molecule which is phenylramidol. So here also you can see that there is the hydroxyl group and amine group. So this is again example for amino alcohol. So here the carbon atom which is bonded to the hydroxyl is numbered as 1 and the adjacent carbon is numbered as 2. And then after numbering, first always number the carbon atoms, and after numbering start with the disconnection. So now here we're going to disconnect the carbon 2 and the nitrogen, and that's why after carbon whatever is the bond we are disconnecting, hence it is called as 1,2 disconnection. So we're going to write down that on the retrosynthetic arrow, and then it is going to give us 2 synthon, which is the alcohol cation, and its synthetic equivalent is going to be the styrene oxide, that is an epoxide. And the next synthetic equivalent that we are getting is the aminopyridine. So these two are the synthetic equivalents. So now whenever you synthesize amino alcohol, the best reagents used for the synthesis is styrene oxide and aminopyridine. These two are the best reagents used for amino alcohol. So wherever you come across a compound with an hydroxyl group and amine group, then it is always amino alcohol. And somehow you have to come to the disconnection, and the starting materials should be an epoxide and a amino group. So make sure that this will be the starting material. So now coming to the synthesis, we are going to use a strong base like a sodamide or liquid ammonia, and we're going to synthesize the target molecule which is phenylramidol. So next we're going to study the example 3. So now here some compounds with heteroatoms on adjacent atoms, for example 1 and 2, these two the target molecules, are considered as derivatives of alcohol. Disconnection gives the synthon and the reagent is an epoxide. So here there is an ester and a chloride group which is the main functional groups in the target molecule, and here you can observe that these two starting materials, these two target molecules are an derivative of alcohol, because see, ester also you can prepare from alcohol, and chloride also by substitution you can prepare from hydroxyl group. On substitution you can prepare a chloride. So the hence you can, first what we're going to do is we're going to interconvert these two functional groups to alcohol. So first, after disconnecting, after writing the hydroxyl group, now we will do the disconnection. So this is again example for 1,2 disconnection, wherein there's presence of alcohol group. So again, the carbon which is attached to the hydroxyl is the carbon number 1, and the adjacent carbon as carbon number 2, and then the carbon 2 and the nucleophile is disconnecting. So hence an example for 1,2 disconnection. So after disconnecting, we are going to write down the synthetic equivalents, which is going to be NuH, and Nu minus is there, that is synthon, and the synthetic equivalent is going to be a hydroxyl abstraction, proton abstraction by the nucleophile, which is going to give us the NuH, and then is going to be the epoxide. So these two are the starting material, and these two starting materials can be used for the synthesis of the target molecule, which is the ester functional group and the chloride functional group. So this is another kind of examples wherein you have to convert the functional group to alcohol and then do the 1,2 disconnection. Next, let us study example 4. Proparacaine is an anesthetic which is used by ophthalmologist. So this is actually an eye drop which is used for eye surgery and laser treatment with respect to the eyes. And these are used by the ophthalmologist, that is the eye surgeons. So here we have the target molecule, that is the proparacaine. Now first here we have an ester. See, whenever you have an ester group along with the other functional groups, always remember that the ester disconnection will be always the first step whenever you're disconnecting, which involves the ester compounds. So hence here, since there is an ester, first we're going to disconnect the ester, that is the carbonyl carbon and the oxygen. So above the retrosynthetic arrow we're going to write down as CO, and then below that we're going to write down as ester. So now after the first disconnection, we're going to get two synthetic equivalents. One is the amino benzoic acid, and we're going to get the alcohol. So first let us start with the, see, OPRN is the protecting group for the hydroxyl, because we don't want to get involved in any side reactions for this synthesis. So hence we're going to first protect the hydroxyl group. So this is a protecting group. So first let us conduct the further retrosynthetic synthesis for the alcohol group. See, on further retrosynthesis, this is nothing but again example for 1,2 disconnection, wherein the alcohol is present, and we're going to do the 1,2 disconnection. So we're going to disconnect the carbon and nitrogen bond. So that is the hydroxyl, the carbon that is attached to hydroxyl is carbon number 1, and the adjacent carbon, carbon number 2, and then disconnection is between the carbon number 2 and the amine, diethylamine. So hence we are going to disconnect the CN bond, and we are going to write down as 1,2 disconnection above the retrosynthetic arrow. So now the synthetic equivalence is going to be diethylamine and the epoxide as the synthetic equivalents for the disconnection of alcohol. So this is the first part is done, that is analysis 1 is done. Now coming to analysis 2, we are going to take up this amino benzoic acid, and this disconnection follows the standard disconnection for the aromatic substitution of the aromatic compounds. That is what we studied in the first few videos. First is what we're going to do is the interconversion of amine to nitro. That is the FGI is going to be conducted. Then we're going to do the CN disconnection, that is the CN is the nitro disconnection we're going to do, which is going to give us the benzoic acid. After this, we are going to remove the protection, that is we're going to do the deprotection process, wherein we are going to disconnect the C and the O group, and we're going to get the hydroxy group. So this is the para-hydroxybenzoic acid as the starting material. So now we are going to use the para-hydroxybenzoic acid, epoxide and diethylamine as the reagents, and we are going to synthesize the target molecule, that is the proparacaine, which is then anesthetic. So here I've mentioned the synthesis. So the synthesis is just, once you write down the retrosynthesis, the synthesis will be the reverse. Just we're going to write down, we're going to follow the same step of the retrosynthesis but in the reverse manner. So this is the synthesis for that particular anesthetic. So next we'll study for the example 5. So this is a bicyclic compound. So here we have a bicyclic compound as a target molecule with the 7-membered nitrogen. That's an azipine group. So first here also we can see that there's an ester group. So first we're going to disconnect the ester group. See, carbonyl group and oxygen is going to be disconnected. So after disconnection, there is the ring opening. The first disconnection is going to give rise to ring opening, and this is going to be an benzoic acid and the alcohol. So after this, again, you can observe that there is an hydroxyl group which is attached to the amine group, and this is going to follow the 1,2 disconnection. So start numbering the carbon atom. The hydroxyl carbon is going to be 1 and the adjacent carbon is number 2, and then we're going to do the disconnection between the carbon and nitrogen. So hence this is again example for 1,2 disconnection. Above the retrosynthetic arrow, you're going to write down as 1,2 disconnection. And after disconnecting, we are going to obtain an orthoamino benzoic acid, and we're going to get the epoxide. So these two are going to be the synthetic equivalents. So the synthetic equivalents, we are going to use that as the starting material. See, epoxide is always a reagent and also the other synthetic starting materials. So these are nothing but the reagents. So we're going to use the reagents and we're going to do the reaction with the POCl3 to give rise to the target molecule. So this is the example 5. Next, we're going to study example 6. So here there are two examples which I have given here. So this is first one is the 1,2 disconnection for the alcohol, and the second one we're going to study is the example for the carbonyl compound. The first one is already what we have discussed earlier. So now let us move to the second one, that is the carbonyl compounds. Sorry. For the carbonyl compounds, the first example is 2,4-D. So 2,4-D is an herbicide which stands for dichlorophenoxyacetic acid. This is a herbicide. Sorry. So after disconnecting the oxygen and the ester group, we are going to give it is going to give rise to the COOH acid group, that is nothing but 2-chloroethanoic acid, and then also there's going to be the formation of the dichlorophenol. So these two are going to be the synthetic equivalents. Now this dichlorophenol can be further disconnected. So here we don't want to disconnect the alcohol group, because alcohol group can be used as the starting material. That is the phenol can be used as the starting material. So we always go with the other choice of disconnection, that is we're going to disconnect the 2 chloro groups. So on the disconnection of the 2 chloro groups, we're going to get the phenol. That's the benzene with the OH group, phenol. So now phenol we're going to use as starting material along with the 2-chloroethanoic acid. We're going to use these two as a starting material in presence of NaOH is going to give us the target molecule, that is the 2,4-D, which is nothing but the herbicide, dichlorophenoxyacetic acid. So this kind of disconnection also can be done for carbonyl compounds along with alcohol. That is the 1,2 disconnection approach can be followed for carbonyl group as well as the alcohols. Let's take example 7. So here we have another target molecule which is an ester. So here first we're going to disconnect the CO bond. So here we can start numbering the carbon atoms. So the carbonyl carbon is going to be numbered 1 and the adjacent oxygen group is going to be numbered as 2. That is the heteroatom. And then we're going to disconnect the carbon and the oxygen bond. So hence this again example for 1,2 disconnection. Above the retrosynthetic arrow kindly mention 1,2 DIX, and then we are going to give rise to the 2 synthons and the synthetic equivalents. Now next we're going to write down these synthetic equivalents. So the synthetic equivalents is nothing but the ketone and we have the carboxylic acid. So these 2 synthetic equivalents along with a base like sodium hydrogen carbonate, can give rise to the target molecule. So this kind of examples are the second group of 2-CX disconnection, which is the 1,2 difunctional groups disconnection. So I hope this was sufficient. I will, though I'll include some more examples. I'll make a list of some examples and give it to you as an assignment, or you can just discuss, or you can just write down whenever you're having free time. So this is it for today, students. Thank you very much.